Hello everyone, today we will learn terminal velocity. Whenever any object, any ball or maybe a single water drop is falling any outside liquid, it may be oil, it may be honey or it may be air. Air is also a kind of fluid. So if suppose this liquid drop is falling in the air, it may experience three forces. One force is downward, which is due to gravity mg. One force is Fb, which is buoyant force due to the upthrust force experienced by any object which is inside the fluid. And third force is due to viscosity. Every object inside a liquid experiences a resistance against the flow of the object. For example, when this ball is suppose falling downward, it will experience an upward force due to the viscosity of the liquid. This is not due to the upthrust. Upthrust force is a different, which we learned in grade 9. This Fv force is due to the viscosity of the liquid. So this ball will experience three forces. In condition of equilibrium, these three forces will balance each other. So I can say mg will be equal to Fb plus Fv, where this force is due to gravity. Okay. This force is due to upthrust, and this force is due to viscosity. So using these three forces, we will calculate the terminal velocity. So we should know what is the terminal velocity. Whenever any object is falling in the liquid, initially its speed will increase due to gravity, correct? Because it is falling downward, due to gravitational force, its speed will continue to increase. But these two retarding forces will be in upward direction, which will try to reduce its speed. There will be a point in case of equilibrium where all three forces will balance each other. After that point, the speed of that object or the water drop will not increase anymore, and we can say that drop has achieved terminal velocity. What we can say here is initially its speed will keep on increasing due to gravitational force, but later after some time net acceleration becomes zero. The drop will not accelerate anymore. Why? Because these three forces 1, 2 and 3 will balance each other, and drop will gain a terminal velocity. So let me write down all the forces m into g. The mass formula is volume into density into g. So here is the volume of the drop. You remember V we are taking of the drop into density. Density we are considering of the drop is rho into g. So this is the first, which is downward. Next force is due to upthrust. Fb is due to upthrust. So it is V into density of the liquid. This is what we learned in smaller grades. V into density into G. Correct? So what is V here? This is the V of the drop which is submerged into the liquid. And here this density is taken for liquid, which we are taking sigma, because upthrust force depends on the density of the liquid, not on the density of the object into G. So this is the buoyant force that will be experienced. The third type of force which will be experienced is due to viscosity. So any object is falling through the liquid, it will experience a force due to viscosity. This formula was given by Stokes' theorem. The Stokes' theorem says that force experienced by the object will be 6 pi eta r v. Okay. Now we should know what are the meaning of these letters. So here the meaning of eta is the coefficient of viscosity. R is the radius of the object which is falling, and v is the speed of the object with which it is falling. So these are the three forces which will be experienced by the object. Here in this case we are taking a rain drop. So let me write down in equilibrium equation will be mg is equal to fb plus fv. So it will be mg is v rho g is equal to fb is v sigma g plus this is 6 pi eta rv. Okay. So we are interested to calculate the speed with which it is falling. This is only called terminal velocity. So this can I take this side? So it will be v rho g minus v sigma g is equal to 6 pi eta rv. So what we will get here? V and g common. So we are getting rho minus sigma by 6 pi eta r is equal to v. What I did, this 6 pi eta r is going down. So this is the expression for terminal velocity. So we can write it in this way. Vt is equal to v into g into rho minus sigma by 6 pi eta rv. I'm sorry, only 6 pi eta r. And what is the meaning of all the letters? Here it is. So you can write down the meaning of each letters once again. In this formula, eta is the coefficient of viscosity, r is the radius of the drop which is falling. We are assuming this drop almost to be spherical, the radius which is falling downward. V is the terminal velocity. Capital V is the volume of that ball or the drop which is falling. Rho is the density of the ball. Remember, it is the density of the ball. Sigma is the density of the fluid with which it is falling down. And g is the acceleration due to gravity, 9.8 meter per second. So this is the formula of terminal velocity. Practice it by everyone.